Welcome. Today we're diving in the world of biostatistics, where biology meets statistics. Whether you're working in healthcare, research, or any life sciences, understanding biostatistics is crucial. So let's break it down. So what exactly is biostatistics? To put it simply, biostatistics is the application of statistical methods to biological, medical, and health-related research. It's the toolkit that helps scientists make sense of complex data, from analyzing the effectiveness of a new drug to understanding disease patterns and its causes. First, let's talk about population and samples. Population refers to the entire group we're interested in studying, such as all patients that have cancer. On the other hand, a sample is a smaller and manageable group, drawn from the population that we are studying. In biostatistics, the goal is to ensure that our sample represents the population accurately, so our findings can be generalized. Now let's look at variables. Variables are the characteristics or properties we measure in our study. There are two types of variables: quantitative and qualitative. Quantitative variables are numerical, like age or blood pressure. These are variables that can be counted or measured, while qualitative variables are categorical, like blood type or gender. These variables describes a certain quality or characteristic. The key is to understand the type of variable we want to investigate, because these variables will determine the type of statistical methods we'll use in our study. Biostatistics can be divided into two main branches: descriptive and inferential statistics. Descriptive statistics is all about summarizing and organizing data. Think of it as a big data set and turning it into something digestible like percentages, averages, and graphs. Inferential statistics, on the other hand, is about making predictions or inferences about a population based on our sample data. Let's say after testing a new drug on a sample of patients, we use inferential statistics to predict on how the new drug might work on the entire population. Now let's discuss some common statistical tests that you might encounter. T-tests are used to compare the means of two groups to see if they are statistically different from each other. Chi-squaretest are used to investigate the association between categorical variables. And ANOVA, or analysis of variance, helps compare the means of three or more groups. These tools has its own purpose, depending on what you are trying to investigate. Another important concept of biostatistics are p-values. This little value tells us whether our results are statistically significant. In a simpler term, a low p-value, typically less than 0.05, means that the results are unlikely to have occurred by chance, suggesting that our findings are valid. To wrap it up, biostatistics is the backbone of research in the biological and health sciences. It helps us make informed decisions, identify trends, and ultimately improve health outcomes. Whether you're analyzing data or reading research papers, understanding this fundamental discipline is crucial.